नमस्कार, I am Anand and you are watching Join for Education. In this class, I am going to derive the section formula, which is one of the most important subtopic of vector algebra. As well as I will solve some questions based upon this formula. Let's start the class. So this is the relevant figure. In two cases, we shall discuss about this one in the internally division and in the externally division. So let P and Q be 2 points represented by the position vector OP and vector OQ respectively. With respect to the origin O, then the line segment joining the points P and Q may be divided by a third point, say R, in two ways, internally and externally. Here we intend to find the position vector OR for the point R with respect to the origin O. We take the two cases one by one. So this is the first case internally and this is the second case, this is the externally. So hope that there is no problem to understand the figure and the statement related to this figure. A statement as well as the figure help us to derive the section formula. In class 10 we have already studied about section formula in the chapter of coordinate geometry, but in this class we are going to derive the section formula in the chapter of vector algebra. So let's see. We discuss about these two figures. This figure is related to the internally division or internal division. So PQ divides the point R in the ratio of P is to N. The position vector of OP is vector A. Position vector of OR is the vector R. So we find out here what is the value of vector PR and vector RQ. So let's see one by one. So vector PR equal to here will be OR minus OP, vector OR minus OP. From figure it is clear that the value of OR is vector R and the value of OP is vector A and the value of PR we write down here vector PR. Similarly, vector RQ equal to vector OQ minus vector OR. The value of vector OQ is vector B and value of vector OR is vector R. So here given vector PR is to vector RQ equal to M is to N. So the value of vector PR is vector R minus vector A. For each 2 we write down here by RQ we write down here vector B minus vector R equal to we write down here M by N. After there is no problem to understand up to this step. Now by cross multiplication we write down here N into vector R minus N into vector A equal to M into vector B minus M into vector R. We move this M into vector R in the left hand side, then we get here N into vector R plus M into vector R. Now we move N into vector A in the right hand side, then we get here M into vector B plus N into vector A. Now we take common vector R equal to M into vector B plus N into vector A by here will be M plus N. So after there is no problem to understand up to this step. So this is the derivation of section formula for the internal division. Similarly for external division this one will be for externally it will be vector R equal to M into vector B minus N into vector A by here will be M minus N. So these are the derivation of the what section formula in two cases. In the case of internal division or internally, and in the case of external division or externally. So hope that there is no problem to understand the derivation of internally and externally. Let's see this question based upon this formula. So let's see the solution here. Find the position vector of a point R which divides the line joining the point P and Q, whose position vectors are unit vector I plus unit vector 2j minus unit vector k and minus unit vector I plus unit vector j plus unit vector k respectively in the ratio 2:1 internally and externally. So this figure represent the internally. So from question it is clear that we write down here from question it is clear that here m equal to 2 and n equal to 1, vector a equal to unit vector I plus unit vector 2j minus unit vector k and vector b equal to minus unit vector I plus unit vector j plus unit vector k. In case of internal division, here vector r equal to m into vector b plus n into vector a, by we write down here m plus n. After there is no problem to understand up to this state. After putting the value of m and a and b, we get the value of r. So the value of m is 2 and value of b is minus unit vector I plus unit vector j plus unit vector k plus the value of n is 1, we write down here 1, and the value of vector a is unit vector I plus unit vector 2j minus unit vector k, by we write down here 2 plus 1. After the simple calculation, we get here minus unit vector I plus unit vector 4j plus unit vector k by 2 plus 1 3. Similarly, for the external division, let's see the figure here. This figure represents the external division. In the external division, we write down or recall the formula m into vector b minus n into vector a by m minus n. Now putting the value of m, b, a, then we get here the value of m is 2 and the value of b is minus unit vector I plus unit vector j plus unit vector k minus the value of n is 1 and value of vector a is unit vector I plus unit vector 2j minus unit vector k, by we write down here 2 minus 1. So here will be minus 2i equal to minus unit vector 3i plus 2j minus 2j cancelled out plus 2j minus 2j cancelled out, 2k plus k equal to, we write down here unit vector 3k, 2 minus 1 equal to 1. So these two will be the answer of this question. So after there is no problem to understand the solution of question number 15, which is based upon the section formula, and we have two cases in section formula, internally and externally. So let's see in the zoom mode. So after there is no problem to understand the derivation of the internally or externally of the section formula, as well as the solution of question number 15. In the next video lecture, I will derive some more concept and solve some more question, depends upon the subtopics.